Hello everyone, my name is Kundan Sharma. Today I am here to do numericals on angular momentum, which is chapter 11 of my physics 221 class. Here we are given a playground where there is a uniform density disk of mass 300 kg and its radius is 2 meter. Let's look at that in a diagram. This is a disk with radius 2 meter and its mass is 300 kilograms. And here a child which is 5 meters away from the disk is of mass 400 kilograms and runs at a speed of 3 meter per second on a line tangentially to the disk and jumps onto the outer edge of the disk. So if the disk is initially at rest, we are asked to find how fast does it rotate after the collision. Since we know that the disk is not initially rotating, the initial angular momentum would be solely the momentum of the child. So here our surrounding would be earth, ground and axle. So we are given here the mass of child 40 kilograms, radius of dust 2 meters, velocity with which child is moving is 3 meter per second, and mass of the dust to be 300 kilograms. We know that the formula for angular momentum is thus the initial angular momentum, which is equals to radius cross linear momentum. So to find the magnitude of linear momentum, r would be, we just put the magnitude sign, r magnitude into p magnitude sine theta, since we got to find the angle between these two, and it would be sine theta. And since this is r, the radius, and this is p, the momentum with which the child is running, the angle between them is 90 degree, and sine theta would be sine 90, and the value would be 1. So after plugging the value of mass to be 40 and velocity 3 meter per seconds, we get the angular momentum to be 240 kg meter square per seconds. Now since we know that angular momentum would always be conserved, initial angular momentum would be equals to final angular momentum, and we calculated initial angular momentum to be 240 kg meter square per seconds. And we know that since in the final angular momentum the disk is rotating, the total final angular momentum would be the rotational momentum plus r, which is the radius of the disk, times linear momentum. So equating this final angular momentum with initial angular momentum, we get our equation to be 240 is equals to I omega plus r mv. And to we know that inertia is equal to half mr square, so omega stays omega plus rm, and the velocity would be omega r, and omega is the value we want to find. This is the angular speed of the disk, and we know the value of capital M, which is mass of dust, to be 300 kilograms, the radius to be 2 meters, and omega is the value we want to find. And in here radius is 2 meters, m is the mass of the boy running, which is 40 kilograms, and radius is again 2 meters, and omega is the value we want to find. So there's only one unknown, so our equation looks this like this. So after solving the simple algebra, we get omega to be 0.316 radians per second. So to solve this problem, what we did was that we just compared the initial angular momentum with the final angular momentum. We just equated these two equations and got the value of omega. Therefore we can say that the disk is rotating with the angular speed of 0.316 radians per second. Thank you.